This is the video solutions to the sample midterm for the spring 2021 13-14 course. So on your sample midterm, you have learning objectives. There are 44 learning objectives on there. You need to make sure you know how to do all of the things listed there. Below the 44 objectives, there are sample problems. So there are 21 sample problems that I'm going to work through. I would highly suggest that you do this on your own without any help features. Just kind of pretend like it's the actual midterm and see how far you can get through it. If you can't get through it, then you know you have a lot of work to do. If there's only a few that you didn't know how to do, then that's great. The purpose of this is to use kind of as a guide for those that you had no clue how to start. So you don't have to watch this whole thing. Go through and find the numbers that you didn't know how to work and just watch the details for that problem. Make sure when you're looking at the sample midterm that you memorize all of the formulas that are listed on there. So there's the distance formula, the midpoint formula, the slope formula, etc. You need to have all of those memorized. So this first example, we're given 2 points. Part A, we need to find the midpoint, and part B, we need to find the distance. So in order to do that, you have to have the formulas memorized. So the midpoint formula, this is just the middle point. So this is averaging the 2 points and finding the middle one. So the formula is x1 plus x sub 2 over 2. So you're averaging the 2 x's, and then you're doing the same thing with the y's. So you're adding the 2 y's and dividing it by 2. This is a midpoint, so it's a point, so it's going to be in order to pair. That's why you have the parentheses. So now we'll just plug in the numbers. If you want to label your points, if that helps you, you can. So we have x1 is 4 plus x2 is -3 over 2. y1 is 5 plus y2 is 6 over 2. 4 plus a -3 is a +1, so 1/2 will be the x value. And then 5 plus 6 is 11, so 11/2 would be the y value. Neither of those fractions can be reduced, so this is your midpoint. All right, part B, find the distance between the points P and Q. So the distance formula, you need to have this memorized as well, is the difference between the x's, so x sub 2 minus x sub 1 squared, plus the difference between the y's, so y sub 2 minus y sub 1 squared. If I have my points already labeled, I can just plug everything in. So x2 is -3 minus x1 is 4 squared plus y2 is 6 minus y1 is 5 squared. Now I can continue to try to simplify. So -3 and -4 is -7 squared plus 6 minus 5 is 1 squared. So -7 squared is 49. 1 squared is 1. So this ends up being the square root of 50. And then it doesn't specify what form your answer should take, so you want to leave it in exact form. So you don't want to make this into a decimal, because then you'd be rounding. But what you do want to do is simplify the radical. So we can do the 50, that is 5 and 10. 10 is 5 and 2. And so we have a pair of 5s, so that comes out of the radical. The 2 is by itself, so it stays under the radical. So 5 square root of 2. And some of your calculators will do this for you. So 5 square root of 2 is the simplified radical. And so that would be the distance. Now remember, if You know, if the test asks you to find an estimate or round, then you can do that by simply, you know, finding the square root of 50 in your calculator. And, you know, if you needed to do that, you wanted to round to the nearest, I don't know, hundredths, you would get that, 7.07, okay? And that's only if it asks for that. In this case, it didn't. But just be aware that that could be a possibility. All right, number 2. Given points P and Q, find the slope of the line passing through the points. So that's part A. And part B is find an equation of the line passing through the points P and Q and write this equation in point slope form. All right, so we can go ahead and label the points if we want. So x1, y1, x2, y2. Again, this is stuff you have to have memorized. So the slope given 2 points is a lowercase m, and that's the difference in y's over the difference in x's. So now we can just plug in what we have. So it would be 6 minus 5 over negative 3 minus 4. So that would be a 1 over negative 7. So our slope is negative 1/7. That's what it asks us to find in part A. So there we go. All right, part B is find an equation of the line. Whenever you're finding an equation of a line, you need 2 pieces of information. You need a slope, well, we found that in part A, and you need a point. It doesn't matter which point you use, so I'm going to choose this point just because it's the first one. There are no negatives, so that's the one I'm going to choose. So what you want to do here is you want to use the point slope form of the line. The point slope form of a line is y minus y sub 1 is equal to m times x minus x sub 1. Since it says write this equation in point slope form, all you have to do is plug in the information given and leave it in that form. You don't have to transform the equation at all. So this would be y minus y sub 1 is 5 is equal to m times x minus x sub 1 is 4. Okay, this is literally what it asks you to do. That's it. That's all you have to do. Now, if, because it's possible that they could do this, if it asks for your answer in slope-intercept form, remember that that means you have to write it in y equals mx plus b form. So if you had to do that, you would start with the point slope form like you have over on the left, and then you would just simplify. So, whoops. You would distribute the negative 1/7. So you would have y minus 5 is equal to negative 1/7 x, and then negative times a negative is a positive 4/7. And then you would have to get the y by itself, so you'd add 5. So you would get y equals negative 1/7 x. You've got 4/7 plus 5 over 1. You want to have a common denominator of 7. So you're going to you're going to multiply by a factor of 7. So then you'll have 4 over 7 plus 35 over 7. That would be your common denominator. And you would get 39 over 7. And so that would be your equation in slope-intercept form if you had to transform it. So again, in this question, it doesn't ask you to do that. You would stop over here on the left with this. But if it asks you to write it in slope-intercept form, you should know how to do that as well. All right, number 3. Consider the quadratic equation x squared minus 6x equals 27. Solve the quadratic equation by factoring is part A. And notice part B is solve the quadratic equation by completing the square. You have to solve by the method asked for, or it will not be given credit. So that's really important that you know how to do this in different ways. So by factoring, if you're going to factor, you have to have the equation set equal to 0. So that's the first thing you want to do. So that means you're going to need to subtract 27 from both sides. So you will get x squared minus 6x minus 27 is equal to 0. So again, when you're solving by factoring, you need it set equal to 0. And now we're going to factor. So there's not a number other than the 1 in front of the x squared. So we're just going to ask what multiplies to get negative 27 and what adds to get negative 6. So we want the product to be negative 27 and the sum to be negative 6. And if you don't know right off the top of your head, that's fine. Go through and write down all the numbers that multiply to get 27. So 1 times 27, 3 times 9, I think that's it, right? So which one of these pairs would add or subtract to get 6? You can see 3 and 9, the difference is 6. So now you just have to manipulate the signs. So if I make the 9 be negative, 3 times negative 9 is a negative 27, and 3 plus a negative 9 is a negative 6. So these are the two numbers that will work. So those are the two numbers we're going to use in our factors. So we'll have x plus 3 and x minus 9. And again, the plus 3 and the minus 9 come from the chart. Now, since I have it factored, I can set each factor equal to 0 and solve each linear equation separately because of the 0 factor property. So I'm going to subtract 3 from both sides here, and I will get x equals negative 3. And I'm going to add 9 to both sides here, so I can get the x by itself, and I get x equals 9. So my two solutions are negative 3 and 9. On the midterm, you can either, box them both in. You can write them in set notation, like that. But make sure you do not put them in parentheses, okay? So do not do this. That is completely incorrect. If you put parentheses, that means that you're either saying there's an interval of answers or you're saying this is an ordered pair, and that is not the case here. So this is not okay. So do not put parentheses around solutions when you have like a finite set of solutions. All right, so let's look at B. B, we need to solve by completing the square. So let's start by writing down what we have. X squared minus 6x equals 27. Okay. So for completing the square, you want everything with a variable or everything with an x on the left and everything without an x on the right. So it's set up the way we want it. What I want to do is I want to make the left-hand side factorable. And in fact, I want it to be a perfect square trinomial. So what that means is I need to fill in a blank on the left so that I'll have a trinomial that will factor. But whatever I do to one side of the equation, I have to do to the other to keep it balanced. So what you want to do is put a plus blank on both sides. You're going to fill in the blank by using the number in front of the x. And you'll always do the same process. You take the number in front of x, divide by 2. In this case, we get negative 3, and then square that. Since you're squaring, you will always get a positive. That's why you will always have a plus blank. So we're going to put a 9 in both of the blanks. So again, you always take the number in front of the x, that's b, you divide by 2 and square it, and you get the number that goes in the blank. Now what goes on the left-hand side, this is always going to factor into something squared. It always factors into the variable, so x, because x times x is x squared, and then you take the 9 and you take the square root of that, and that's what goes here. The sign always matches the sign from here, okay? And the reason this works is because negative 3 times negative 3 gives you the positive 9 at the end, and negative 3 plus negative 3 gives you the negative 6 in the middle. This is always how this will work. It will always be a binomial squared. And then on the right-hand side, you're going to combine like terms, and so you'll get 36. Now, you have set it up to where you can complete the square. I mean, you just completed the square. You set it up where you can do the square root property. So we're going to use the square root property. Since everything on the left-hand side is squared, you can undo that by square rooting. Whatever you do to one side, you do to the other. And you always have to put plus or minus in when you put in a square root where it wasn't before. So the square root undoes the square. So on the left-hand side, you'll just have x minus 3 left. On the right-hand side, you have plus or minus. The square root of 36 is 6. And then the last step is to get the x by itself. So we're going to add 3 to both sides. So x equals, biggest mistake that's made here is people say plus or minus 9. That is incorrect. This means 3 plus or minus 6. This means 3 plus 6 or 3 minus 6. You can see 3 plus 6 is 9, but 3 minus 6 is not a negative 9. This is a negative 3. So you have to make sure you do not simply add these numbers and say plus or minus 9, because you'll get one of them right and one of them wrong. So this will be 9 or negative 3. Those are your two answers. Okay, so let me see. Here are our answers here. Keep in mind, since you just solved the same equation by factoring in part A, you should be getting the same answers. If you're not getting the same answers, then you did something wrong in one of these or both of them. So that's something, that should be a clue that you need to check your work. Okay, number 4, solve the equation. So this is a radical equation. What you want to do first is make sure the square root is by itself on one side of the equal sign. In this case, it is. And so then you undo the square root by squaring. So we're going to square both sides. The square undoes the square root, and so that's going to give you 4x plus 28 is equal to x minus 1 squared means x minus 1 times x minus 1. So you're going to have to distribute this all the way out. Some people say FOIL. Okay. So you'll have 4x plus 28 is equal to x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. Combine like terms. Okay, so we have 4x plus 28 is equal to x squared minus 2x plus 1. Now you want to look and see what kind of equation you have here. You have a quadratic equation because of the x squared. So if you have a quadratic, you have to get everything set on one side of the equal sign and set it equal to 0. So subtract 4x from both sides. Subtract 28 from both sides. So I'm bringing everything over to be on the side of the positive x squared. So we'll have x squared minus 6x minus 27 is equal to 0. If you pay attention, this equation is the equation you just solved up here. X squared minus 6x minus 27 equals 0. So we've already solved this equation. So I can kind of skip the work. We've done the work above. So x equals, I believe we had 9 and negative 3. Yes. All right, x equals 9 and x equals negative 3. Now, here is the thing you have to remember. When you're solving a radical equation, you have to check your answers to make sure they work. So you want to check these. So the first one I'm going to check is the 9. You have to plug it into the original equation. So we have 4 times 9 plus 28, all under the radical, is equal to 9 minus 1. All right, so 4 times 9, that's 36. And then plus 28, that gives you 64. So the square root of 64 is equal to 8. Square root of 64 is 8. 8 equals 8. Well, that's a true statement. So 9 is an answer. So I'm going to go ahead and box that one in. All right, now I'm going to check -3. So check x equals -3. All right, so we have the square root of 4 times -3 plus 28, all under the square root, is equal to -3 minus 1. So 4 times -3 is -12, plus 28 is 16. So this is the square root of 16. The square root of 16 is 4. -3 minus 1 is -4. So I have 4 equals -4. Well, that is not true. That means -3 is not a valid solution. So the only answer to this one is 9. So for number 3, both parts we get 9 and -3. For number 4, only the answer is 9 because the -3 does not check. So the whole point of this one is to make sure you know to check your work for the radical equations. Okay, number 5. This is an absolute value inequality. So it says solve the inequality and express your answer in interval notation. So the first thing you want to do is say, okay, do I have the absolute value by itself on one side of the inequality symbol? Yes. Next, you want to look and see if you're comparing to a positive number. You are, so you can continue forward. Next, you want to look at the symbol that you have here. This is a greater than. Okay. So a greater than, you should branch off into 2 inequalities. So you'll have -3x plus 1 is greater than 10 as one inequality to solve. And then you'll also have -3x plus 1 is less than a -10. So for the first inequality, you leave everything alone. You just drop the absolute value symbols. For the second inequality, you have to flip the inequality symbol and add a negative. Okay, that's what happens here. You flip this and add a negative. And now you're going to solve. So we'll subtract 1 from both sides. So we get -3x is greater than 9. We divide by a -3. So we get x. If you multiply or divide by a negative number, you always have to flip the inequality symbol. That's because it changes the relationship between the two sides. So now you have x is less than a -3. Okay, so we've solved that one. Now we want to do the same thing on the other one. So subtract 1 from both sides here. So we get -3x is less than -11. Divide by -3. We are dividing by a negative here, so we have to flip the inequality symbol. So now it's a greater than. -11 divided by -3 would be +11/3. All right, so now we have the x by itself in both cases, so we're done with the solving portion. Now what we want to do is write it in interval notation. I highly recommend that you graph this and then write it in interval notation just to make sure you have an understanding of what's happening. But if you can go straight to interval notation, that's fine. So the first thing I would ask you to do is to write each boundary point on the line. So I'm going to highlight this one in red and the second one in blue. All right, so my 2 boundary points are -3 and 11/3. So since the -3 is negative, it's going to go to the left because it's less than a +11/3. And now I have to decide how to shade. So for the -3 in red, x is less than -3. So that would be the numbers to the left of -3 are less than -3. So you would shade to the left. And then since it does not have an or equal to under it, this is a strict inequality, you would put a parentheses here. And for those of you who have learned open circle and closed circle, this would be open circle. Okay, and now 11/3. This says x is greater than 11/3. The numbers to the right are greater than, so we're going to shade to the right. Again, this is a strict inequality. It does not have an or equal to under it, so it would be an open circle or a parentheses. Remember, if it had an or equal to sign under it, you would be using square brackets like that. Okay, so now we can see that we have two distinct pieces on this graph. So for each interval that's shaded, we have to have a separate interval notation. So for the red part, the part on the left, it goes to the left forever, so negative infinity, and it goes to the right to -3, parentheses. Remember that negative infinity and infinity always get parentheses because it never reaches that point. And now we're going to say union. So we have another part to our solution set, and that's the blue, or the part on the right. So it starts at 11/3, and it goes forever to the right, so it goes to infinity. All right, so there is the interval notation as asked in the problem. Okay, and make sure you review how to solve an absolute value inequality if you have a less than symbol. And also make sure you remember how to solve these if you're comparing to a negative. So those are all things that you should know how to do. All right, number 6, solve the equation. So on this one, the key here is remembering to rewrite the part on the left using radical notation. And so the way to do that, your x plus 7 is your base. The number on the bottom of the fraction is always going to be the index or the root. And then the number on the top of the fraction is always going to be the exponent. Okay, and then equal to whatever it was equal to, so 81. So again, this number, this 4, the top number is always the exponent, and this bottom number, in this case the 3, is always the index, okay, or the root. So now what you want to do is you want to undo the exponent first. There are other ways to solve this, but if you're not careful, you will end up only getting one answer when you actually should have two. So I highly encourage you to use this method every time to make sure you get all of your roots. Okay. So the fourth power, to undo the fourth power, you need to do the fourth root. Okay. You need to put in a plus or minus because you're putting in a even root, a fourth root. So the fourth root will undo the fourth power. So on the left-hand side, you will have the cube root of x plus 7 left. And on the right-hand side, you'll have plus or minus 3. The fourth root of 81 is like taking the square root twice, so that would be 3. Okay, so now you want to finish by undoing the cube root. To undo the cube root, you need to cube both sides. Okay, so now we have x plus 7 is equal to a positive 3 cubed is a positive 27, and a negative 3 cubed is a negative 27. So we can put plus or minus 27. And then the last step, getting the x by itself, is subtracting 7 from both sides. So we have x equals, again, don't just say plus or minus 20. You have to separate this into cases. So this is the same as negative 7 plus or minus 27. Well, that's negative 7 plus 27, or negative 7 minus 27. So negative 7 plus 27 is 20, and then negative 7 minus 27 is negative 34. Okay. So our two solutions are 20 and negative 34. Now let's look at number 7. So number 7, find the domain of the function f of x and express your answer in interval notation. So remember, the domain is associated with the x values. And in our class, we had two cases where we might have a restriction on the domain, meaning there are problems with some of the x values. So we talked about a fraction, right? And in the case of a fraction, the bottom could not be 0. And so we would have to restrict that domain. We also had another problem with a radical. If it's a square root, that has to be positive. Well, it has to be non-negative. It could be 0, right? So that would be greater than or equal to 0. Okay, in this example, we actually have both happening at the same time. Notice we have a square root and it's in the denominator. So that means that what's in the square root has to be greater than or equal to 0, right? That's how we would normally do a square root. We would say x minus 7 has to be greater than or equal to 0. Okay, but the x minus 7 is in the denominator, which means it can't be 0. So now instead of having is greater than or equal to 0, we're actually going to just say it has to be greater than 0. Okay, so it has to be greater than 0. And that will take care of the fact that it's in the denominator because there's not an equal to sign under it. And it has to be bigger than 0 for the square root. All you do is solve that, and that gives you your domain. So this will be x has to be bigger than 7. Anything that's larger than 7 will work. Anything that's less than 7 will give you an error, or 7 as well will give you an error, and it won't exist. So this is your answer here. You need to write your answer in interval notation. So it has to be greater than 7. Again, if you want to write your number line, put your boundary point on there. X has to be greater than 7, so that's to the right. No or equal to sign, so parentheses. So your interval notation is parentheses 7 to infinity parentheses. Okay, so that is the domain. Again, if you have a radical in the denominator, you take whatever is underneath the radical and you just do greater than 0 and solve. Okay. Number 8. It looks like I'm going to need to make this a little smaller. Okay, so number 8, use the graph of f of x to evaluate the expressions. So you have parts A, B, C, and D. So remember that normally you see f of x, right? So if we look in the directions, we see f of x. So in part A, we have f of 1. So notice that the 1 is taking the place of the x. So they're saying when x is 1, what is y? So here is where x is 1. You're actually on the graph there. So you don't have to go up or down at all. Your y is 0. Okay, let's look at part B. We want to know when x is 4.5, what is y? So we're going to go over to 4.5, so right here. Notice we're not on the graph. In order to be on the graph, we have to go all the way up to here. Okay? So let's see how many dashes there are. There's 1, 2, 3, 4, 5. So this is like 1.2, 1.4, 1.6, 1.8, 2. 2.2 is here, so it's a little bit over that line. So let's say 2.25 would be the y value. So when x is 4.5, y is 2.25. All right, part C. If x is 2.5, what's y? So I'm going to go over to 2.5 on the x-axis, and then I have to find the y value. So it's here. Again, that's a little bit over the 0.2. So I'm going to say 0.25. So 1.25. If it's somewhere close, you know, you're going to get credit. As long as you know that these are going in increments of 2, 0.2, 0.4, etc., and you figure out a number that makes sense, that's fine. If you said 1.21, 1.27, I would think that they would give you credit, okay? If you say something like 1 or 1.8 or something that does not make sense, you would not get credit. So just make sure your answer is reasonable. Okay, f of 0.5. So when x is 1/2, when x is 0.5, what is y? So 0.5 is between the 0 and the 1. So I would say somewhere right around here. It's right above this line. So I would say 0.25 again. I'm just using the 25. So whenever you're given something like this, it's giving you the x. It wants the y value of the ordered pair that appears on the graph. All right, number 9. This is a little bit different. They're giving you a chart. So consider the functions f of x and g of x defined by the following tables, and then evaluate the following expressions. So for part A, you are going to have, this is the same as f of 4 plus g of 4. So what you want to do is go to the chart. X is 4. So when x is 4, f of x is 2.3. So this would be 2.3. Now you're going to do the same thing for the g. When x is 4, g is 3.31. So you're going to put plus 3.31. And then you're simply going to add those together. So 2.3 plus 3.31 gives you 5.61. Okay, so there is your answer for part A. Okay, let's erase that in the chart. Let's look at part B. So part B, f times g of 5. So this is the same as f of 5 times g of 5. So I'm going to go to the chart. When x is 5, f is 4. So this is going to be 4 times, when x is 5, g is 3. So this is going to be 3. So 4 times 3 is 12. So there is your answer for part B. All right, now let's look at part C. Part C is f divided by g of 3. This is the same as f of 3 divided by g of 3. Okay, so when x is 3, f is -1. So -1 over, when x is 3, g is 1. So this is a 1. -1 divided by 1 is -1. So there is your answer for part C. Okay, part D, you see this little open circle? This means a composition. So this is g of f of 5. So remember that this is the same as g of f of 5. So you always work from the inside out. So the first thing you want to do is find out what you would get for f of 5. Okay, so let me see. You're trying to solve the inside stuff first. So the first thing you want to do is you want to look up in your chart for f. Whenever x is 5, whenever x is 5, f is 4. So this is going to be 4. The answer to f of 5 is 4. So this is going to be g of 4. Now you're going to find g of 4. So whenever x is 4, g is 3.31. So this is 3.31. And that's your answer. So always work from the inside out. So first you find f of 5, and that was 4. Then you find g of 4, and that's 3.31. Okay. All right, number 10. Solve the equation. Okay, so the first thing that I notice here is that we have an x to the 4th, but then I notice that all of the terms have variables. They all have at least x squared. So I can factor that out. So I'm going to have x squared. If I factor something out, remember that means I'm dividing it out. So I'm dividing x squared out of each term. So I'm going to have x squared minus 6x plus 27 equals 0. Okay, so now this is very similar to what we had earlier, except we had a minus 27 instead of a plus. So I'm going to factor what's in parentheses again. So I have x squared. Can I? It has to add to get negative 6, but multiply to get positive 27. I'm actually not going to be able to factor that, I don't think. So let us do it like this. So what you want to do is set each factor equal to 0 separately and solve. So that one is solved. If I, do the square root of both sides, there is no plus or minus 0, so the answer here would just be 0. Okay? Then I also have to solve x squared minus 6x plus 27 equals 0. We're going to do the quadratic formula here. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So remember that a is in front of the x squared, so in this case that's a 1. B is in front of the x, so that's negative 6. And c is the constant, so that's 27. So I'm going to plug everything in. So I have the opposite of b. So negative 6. That will be a positive 6 is equal to b squared, so negative 6 squared, minus 4 times a, which is 1, times c, which is 27, all over 2 times a, which is 1. Okay, so now I'm going to have 6 plus or minus the square root. Negative 6 squared is a positive 36. And then you have negative 4 times 1 times 27. So that'll be minus 108 all over 2. Okay, I ran out of room, so I'm going to go over here. 36 minus 108 is negative 72. So I'm going to have 6 plus or minus the square root of negative 72 all over 2. All right, I'm going to keep going. So 72, I need to try to reduce that. So I'm going to make a factor tree. So 72, that is 9 times 8. That's 3 times 3. 2 times 4. 4 is 2 times 2. All right, so a 3 will come out, a 2 will come out, a 2 will stay under. So that will be 6 square root of 2. So we'll have 6 plus or minus, okay, the negative comes out as an I also. So we're going to have 6i square root 2 over 2. Okay, so again, the negative in front of that 72 comes out as an I. Now what we want to do is reduce. So we can divide each piece by 2. So we're going to have 3 plus or minus 3i square root 2. All right, so here are our solutions. We've got 2 solutions here. We have 1 solution here, which is actually 2, right? 0 is twice, so that's all of our solutions. All right. Okay. Number 11, determine if the function is even, odd, or neither. So in this example, if a function is even, so a little bit of side notes here, if a function is even, then it satisfies the condition that f of x is equal to f of negative x. Okay? If it's odd, then it will satisfy the condition that f of x is equal to negative f of negative x. So you can use those to check if it's odd or even. If it's not even and it's not odd, then you just say it's neither. So I always like to start by checking even every single time. And so if I'm going to check even, I need to show that f of x is equal to f of negative x. That means I need to find what f of negative x is. So to check even, I need to find f of negative x. That means I plug in negative x everywhere where there is an x. Okay, so let's see what happens here. This negative x squared, the square is going to make that positive. So that's just going to be 3x squared. And then this absolute value of negative x, whatever is in the absolute value comes out as a positive. So that's going to be 3 absolute value of x. This looks exactly like the original. If I plug in a negative x, it makes no difference. So this is an even function. Okay, so if you can plug in a negative x and you simplify and end up with exactly the same thing you started with, that means it's an even function. All right, and you're done. If it's even, then obviously it's not odd. It's one or the other. So part B, I'm going to check to see if this is an even function. So I'm going to find what f of negative x is. So, oh, this time it's s, so let me change that. F of negative s is, so that's 4 times negative s cubed minus 7 times negative s. And so negative s cubed, since it's a cubed, it's going to remain negative, so I can put it out front. So this will be a negative 4s cubed, and negative 7 times negative s, that would be a positive 7s. So you can see that this is not the same as what I started with. Both of the signs have changed. That means it's not even. Okay, so now I want to try odd. The way you check to see if it's odd is you want it to be the opposite of what you just found. So all you do is change all the signs, basically. So you're going to make it a negative of what you just had up here. So see, this is what's in parentheses. I want the opposite of that, so I'm going to change all of the signs. And if I do that, I get positive 4s cubed minus 7s. And now you can see this is exactly what I started with originally. That means it is odd. Okay. So part A is even, part B is odd. And that's how you show it. Number 12. Find the inverse of the function g of x is equal to negative 1 over x plus 2. To find the inverse of a function, the first thing you want to do, well, the first thing I like to do is rewrite the function value here with a y, and then you interchange the x and the y. So this is going to look like x is equal to negative 1 over y plus 2. So you switch around the x and the y, and then you solve for the new y. So I need to get the y by itself. So the first issue is the y is in the denominator. So I'm going to fix that by multiplying both sides by that denominator. So I will have y plus 2 times x is equal to negative 1. Now I can divide both sides by x. So that's going to give me y plus 2 is equal to negative 1 over x. Then I can subtract 2 from both sides. So that gives me y is equal to negative 1 over x minus 2. Generally, the last step is to write it in inverse notation. And so you just change the y into f inverse of x, and then everything else stays the same. So that would be the inverse of the original function f. Or actually, was it a g? I've scribbled it out, so I don't know. Let's see. It was a g. So I need to actually write a g here. Okay, so g inverse of x. That's what I find. Okay. Number 13. So let f of x be that and g of x be that. Compute the following. Simplify your answer as best as possible. Okay, so f of g of x. So that means I'm going to take, I'm going to take g and put it into f. So here is g, and I want to put that into f. So everywhere I see an x is going to become that. So that's going to give me x squared, so 2x plus 1 squared, plus x, 2x plus 1. All right, so I'm going to have to do some scratch work here. 2x plus 1 squared. So let's go over here. That means 2x plus 1 times 2x plus 1. That's going to give us 4x squared plus 2x plus 2x plus 1. So that would be 4x squared plus 4x plus 1. Okay, so we'll have 4x squared plus 4x plus 1, and then we have plus 2x plus 1. Combining like terms, we get 4x squared plus 6x plus 2. That's as far as we can take that, so that is the answer for part A. Okay, now we want to look at part B. So for part B, we have g of f of x. So here we have f of x, and we're plugging that into g. So here is f of x, and we want to plug that in everywhere we see an x in the g part. So that's going to give us 2 times x squared plus x plus 1. So distribute the 2, we get 2x squared plus 2x plus 1. There are no like terms, so that is all we can do to that one. Okay, number 14. All right, so Mrs. Smith wants to pave a walkway around the perimeter of her garden that measures 8 feet wide and 15 feet long. Find the width of the walkway if the total perimeter is 66 feet around the outside edge. So let's draw a diagram, figure out what is even going on. So it doesn't say this, but I'm assuming that it is a rectangle. So we're going to assume that the walkway and the garden is rectangular shaped. So 8 feet wide and 15 feet long. There's a walkway around it. So here's a garden in the middle, and then there's the walkway around it. Mrs. Smith wants to pave a walkway around the perimeter of her garden that measures 8 feet and 15 feet. So I'm going to, 8 and 15 is the width and the length of the garden. Find the width of the walkway if the total perimeter is 66 feet around the outside edge. Assuming that means the outside edge of the walkway. All right, so now we have x here. So if the width of the garden is x, so x, not the garden, is the width of the walkway. So the width of the walkway is going to be x. That means I have a 15 and I have an x and an x. So if I want the outside edge of the walkway, the length here, I would have 15 plus these two x pieces. So this would be 15 plus 2x. Okay? And then I could do the same thing for the width. This is also x, this is 8. So the entire width of the walkway would be 8 plus 2x. Okay, so now I have that, and it says find the width of the walkway if the total perimeter, I'm guessing of the walkway, is 66 feet. So that means both widths and both lengths. You add up all the sides to get the perimeter. So I would have 15 plus 2x and another 15 plus 2x because I have two lengths. I would have 8 plus 2x and another 8 plus 2x because I have two widths is equal to 66. And then I would solve that equation. So we'd have, let's see, 2, 4, 6, 8x. 15 and 15 is 30, plus 8 is 46, is equal to 66. And so now we would solve this. So subtract 46 from both sides. So we get 8x is equal to 20. Divide by 8. So we get x equals 20 divided by 8 is 2.5. Okay, and it was given in feet. So it wanted to know, find the width of the walkway. So here we go. The width of the walkway is 2.5 feet. Okay, whoops. The next word problem is a mixture problem. So Dr. Pollard poured 22 grams of 7% alcohol solution into a large mixing container. He had plenty of 16% alcohol on hand. Let X represent the number of grams of the 16% solution. How much of the 16% solution did he need to pour into the container in order to have a 12% solution for his lab experiment? To figure this one out, I would highly recommend organizing your information. It doesn't have to be a chart. It can just be together. So here's how I would do it. You have 22 grams of 7% alcohol. So the first thing I'm going to look at is all the different percentages of alcohol we're talking about. We've got a 7% solution, a 16% solution. It mentions a 16% solution a couple more times, and then a 12% solution. So in general, for our class, we're going to be talking about 3 different solutions. So you're mixing 2 together to get a third. So we're talking about a 7% solution, a 16% solution, and then our mixture is going to be 12%. So you kind of want to put the mixture or what you're trying to get at the end. So it's on the right side. So the first row is your percentages. The second row is how much of each solution you're using. So it tells you, let's do this in red, I guess. It tells you that you're using 22 grams of the 7%. So I'm going to put 22 grams here. The 16% solution, it doesn't tell you how much, but it says let X represent the amount of grams you're going to use of the 16%, so you know that that's going to be X. And then you don't know how much you're using of the 12%, but think about it this way. If you're adding the 7% plus the 16%, so you're dumping 2 solutions together, the total number of grams is going to be the addition or the sum of what you just put together in the same bucket. So 22 plus X is how much you're going to end up making in the end. So if you use 22 grams of the 7% and X grams of the 16%, the total is you're just summing that up, and that's how much total you're going to have at the end. So 22 plus X. The way you set up your equation is you multiply pieces, okay, straight down. It's the first mixture plus the second mixture gives you the final mixture, right? So the first amount of the solution plus the second amount of the second solution is equal to the total, your mixture. So you're going to write 7% as a decimal, so 0.07 times 22. So you're multiplying straight down. Plus 0.16 times X is equal to 0.12 times 22 plus X. That's how you're going to set up your equation. And now you're going to solve. So we're going to multiply. So 0.07 times 22, that will be 1.54. Okay, 0.16 times X is 0.16X is equal to 0.12 times 22 is 2.64. 0.12 times X is 0.12X. Okay, now we want to get all of our X's on one side and our numbers on the other. So I'm going to move the X's to the left. So minus 0.12X, minus 0.12X, and I'm going to move my constants to the right. So minus 1.54, minus 1.54. All right, so if I do that, I'm going to move it over here. I've got 0.16 times, or minus 0.12, that'll be 0.04X, is equal to 2.64 minus 1.54. That gives me 1.1. All right, and then the last step is to divide by 0.04. So we will get X equals 1.1 divided by 0.04 is equal to 27.5. So we found X. We said X was the number of grams of the 16% solution that was used. And that's what we're asking for. How much of the 16% solution did he need? So this is in grams. So 27.5 grams. All right, number 16, part A and part B. Use the vertical line test to determine if the relation is a function. So a vertical line test. You're just going to draw a vertical line anywhere through the graph. If any vertical line that you draw will pass through the graph more than once, it's not a function. So this is not a function because a vertical line will pass through it more than once. The horizontal line test is used to determine if a function is one-to-one. So this one, if I use a horizontal line test, I can see that it passes through more than once. So this is not a one-to-one function. Okay, so it's that easy. Vertical line test shows it's not a function for part A, and then part B, the horizontal line test, it passes through more than once, so that shows it's not one-to-one. All right, number 17, determine the domain and range of the functions graphed below. Express your answer in interval notation. So the domain is x values. That's left to right. So your domain is going to be how far left does the graph go and how far right does the graph go. So this is the furthest left we get. So we can see that that is 0. And so it's an open circle at 0. That means 0 is not included. So it's going to be a parentheses. And then it goes all the way over to this dot, which is the 3. It's a closed circle, so that will be a bracket. So the domain from left to right is 0 to 3. The range, so the range is the y values, and that's bottom to top. So we can see the lowest we get is right here at the 0. Again, it's open circle, so it would be a parentheses 0. And then the top it gets is here, which is right around here. Now it looks like it's right between the 1 and the 2, right in the middle. So let's say 1.5. And since it's a closed circle, you would have a bracket. Okay. Part B, we have the same directions. So the domain and range. So the domain, again, is the x values. So I'll be left to right. So the leftmost value is here. That's at the 0. It's a closed circle, so it gets a bracket. And the rightmost point is here. It's also a closed circle. It's associated with the x value of 2, so it gets a bracket. All right, range is bottom to top. The lowest values happen right here, and it happens more than once, but that's as low as the graph gets. And that's associated with a y value of -1. You assume that it reaches that point, so you use a bracket. And then the highest value is up here. These are the peaks, right? And you can see that's associated with a y value of 1. And again, you use a bracket because you assume it reaches that point. So there's your range. Number 18, find the average rate of change of f of x is equal to x squared plus 1 over the interval 0, 3. Here is the key to this one. These are x values in this interval, okay? This is a low to a high of x values. So they're giving you this interval of x values, and they want you to find the average rate of change using these two end points. And you need to find the y values. So this is kind of similar to a slope in a way. So what you're going to do is you're going to find f of 0, so this is the y value, by plugging in the x values. So this would be 0 squared plus 1. Well, that's going to be 0 plus 1, which is 1. So f of 0 is 1. Notice you're finding an ordered pair. X was 0, y was 1. All right, now we're going to find another one for the 3. So f of 3 equals 3 squared plus 1. Again, what I'm doing is I'm using 0 and 3 from what was given in the equation, right? So I'm going to have 3 squared is 9. 9 plus 1 is 10. Again, I have another ordered pair of 3, 10. To find the average rate of change, that is the slope formula, okay? It is the difference in y's over the difference in x's. So you're simply going to treat these, okay, as x and y. Use the slope formula because the average rate of change formula is the same as the slope formula. And you're just going to solve. So we'll have y2 minus y1 over x2 minus x1. So that would be 9 over 3, which is 3. So the average rate of change is 3. Okay, number 19. Write your answer to the following complex computations in the form a plus bi, where a and b are real numbers. So part A, you're just multiplying these two complex numbers. So you're going to distribute. So negative 4 times 2 is negative 8. Negative 4 times negative I is plus 4i. 3i times 2 is plus 6i. 3i times negative I is negative 3i squared. Okay, so now you want to combine like terms and simplify here. So remember, whenever you see an I squared, that is the same as a negative 1. You never want an exponent on an I or it's not considered simplified. So we're going to change I squares to negative 1s, combine our like terms here. So that's going to give us negative 8 plus 10i. Negative 3 times negative 1 is plus 3. All right, and then the last step is combining the real parts. So negative 8 plus 3 is negative 5 plus 10i, and that is our answer. Notice I have the negative 5 first and the 10i last. That is in a plus bi form. So you would not want to give your answer as 10i minus 5 because that would be not in the correct form. So make sure you put your real part first and the imaginary part second. All right, part B, we want to rewrite this. So we need to get rid of this I in the denominator. If you have a complex number on the bottom, you want to multiply by the complex conjugate. That is the same two terms with a different middle sign. So you're going to be multiplying by 2 minus I. So when you do that, you've got to distribute all the way out. So 1 times 2 is 2. 1 times I is negative I. 3i times 2 is 6i. And 3i times negative I is negative 3i squared. That's the numerator. In the denominator, we'll have 2 times 2 is 4. 2 times negative I is negative 2i. I times 2 is plus 2i. And then I times negative I is negative I squared. Everywhere we're seeing I squared, that's going to become a negative 1. Now we can combine like terms. So 2 plus 5i plus 3 over these two i's cancel out. So this will be 4 negative 1, so plus 1. All right, so then we have 2 plus 3 is 5. So 5 plus 5i over 5. And you can see that the 5s are going to divide out. So we'll have 1 plus I. So there is the answer to that one. All right, almost at the end here. Number 20, determine the x and y intercepts of this equation. So to find the x-intercepts or intercept, you let y equal 0. And to find the y-intercept or intercepts, depending on your situation, you let x be 0. So whatever intercept you're trying to find, you let the other variable be 0. So in the x-intercept I'm going to have 8x minus 9y, but I'm going to plug in 0 for y, is equal to 72. So that's going to be 8x is equal to 72. Divide by 8. So x equals 9. All right, we're finding intercepts, so we need to write it as an ordered pair. So the x-intercept, x is 9, y was 0, so there's your intercept. You cannot just leave it at x equals 9 because that's not in intercept form. We're asked to find an intercept, so you have to write it as an ordered pair. For the y-intercept, I'm going to have 8 times 0 minus 9y is equal to 72. So that's going to be negative 9y is equal to 72. Divide by negative 9. So y would be equal to negative 8. Again, I need it in intercept form. X was 0, y is negative 8. So there is my y-intercept. All right, the last one, number 21. So solve the equation. This one is kind of tricky because there are 2 square roots within the same problem. So in order to start, you have to get one of the square roots by itself. So the first thing you really want to do is move one of the square roots. It really doesn't matter which one. I just chose to move this one, but it doesn't matter by subtracting it. So you're going to have the square root of x minus 1 is equal to 5 minus the square root of x plus 3. Now that you have the square root of x minus 1 that's by itself on one side, you can square both sides of the equation. So the left-hand side is going to give you x minus 1. And then the right-hand side, this is going to get kind of nasty here. We've got to multiply out this. Okay, so this is going to be 5 times 5 is 25. 5 times the negative square root of x plus 3. That's going to be negative 5 square root x plus 3. Then another negative 5 square root x plus 3. And then the square root of x plus 3 squared, that's just plus x plus 3. So it comes out of the radical. All right, so now we have an x. We have 25 plus 3 is 28. And we have negative 10 times the square root of x plus 3. Okay, so I did this plus this, gave us this, just to make sure we see the parts that where they went. 25 and 3 gave me the 28. And then I have just the x, right? Okay, so that is going to go over here. X plus 28 minus 10 times the square root of x plus 3. Okay, so now your goal is to get that square root. That's the only square root left now in the problem. Get that one by itself. So I'm going to subtract x from both sides, subtract 28 from both sides. Okay. So now I'm going to have negative 29 is equal to negative 10 times the square root of x plus 3. So I can divide both sides by negative 10. Again, I'm trying to get the square root by itself. So this would be the square root of x plus 3 is equal to 29 over 10, because the two negatives would cancel on that side. Now I'm going to square both sides, and that's going to get rid of the square root. So x plus 3 is equal to 29 times 29 is equal to 841 over 100. And then the last step is subtract 3. So x equals, this would be the same as 841 over 100 minus 300 over 100. So that would be 541 over 100. Okay, so that is my proposed solution. Unfortunately, now that I've done all that, I have to check the solution. So let's check. x equals 541 over 100. All right, so I'll have the square root of 541 over 100 minus 1 plus the square root of 541 over 100 plus 3 is equal to 5. Okay, so the first one is going to be 441 over 100. So the square root of 441 is 21. So this is going to be 21 over 10 plus 541 plus 300 is 841. So that's going to be 841 over 100. Square root of 841 is 29. Okay, so 21 plus 29 is equal to 50. And 50 over 10 is 5. That does equal 5, so it checks. So here is our solution for that one. So this one is longer. You've got to do this kind of process to get rid of radicals twice, and then don't forget to check your work.